today's video, we'll walk you through performing simple regression, a scatter plot, and calculating the predictive and confidence intervals using SPSS. So we have this data set here, TV ads and car sales. Our dependent variable is car sales. Our independent variable is TV ads. Because if you think logically, as I increase the number of TV ads, I should increase the number of cars sold. So the first thing we're going to do is create our scatter plot. We go into graphs and then legacy dialogues, scatter and dot. Select a simple scatter plot and click define. Our y-axis is our dependent variable, which is going to be car sales, and our x-axis is our independent variable, which is TV ads, and we click OK. It brings up our output here of our scatter plot. We can click on here and have it draw a line for us. We can edit this in pretty much any way that we want. We can click right there. That should be add a fit line. There you go. So that gives you your best fit line with your associated R squared. So this tells us that our R squared is 83%. So TV ads explain 83% of our car sales. The next thing I want to do is actually go and perform my regression. So I will go back to my data set and click on Analyze, Regression, and then select Linear Regression. My dependent variable is car sales, and my independent variable is TV ads. I can determine a whole bunch of different things here. For statistics, let's go in here. I want my 95% confidence interval, so I'll check that off. I'm also interested in descriptive statistics, so I'll click continue and that'll put that in there. Then in order to do my predictive interval and my confidence interval of my prediction, I'll need to click on this save section. And I want to save under predicted values, I want to save unstandardized. And under predictive interval, I would like the mean and individual. Click continue there and then click OK. So here I have my descriptive statistics. My X bar, my average number of cars sold is 18. My average number of TV ads was 2. Standard deviation of car sales is 3.83 cars. Standard deviation of TV ads is 1. I can see that there is a strong correlation between TV ads and car sales. So 91% is a pretty strong correlation. I can scroll down here to get my R squared, which tells me the percentage variation in my dependent variable explained by my regression. So this tells me that roughly 83% of car sales are explained by my regression. Down in my ANOVA, I can look at my significance of F. That's my p-value of my F statistic. My F statistic tests that all of my independent variables together have no impact on my dependent variable, and that's less than 0.05. So that tells me I would reject HO, and I'll conclude that at least one of my independent variables has a statistically significant impact on my dependent variable. Now here you'll notice the significance of F and the significance of T down here are the same number because there's only one independent variable. So I'll go down here into this coefficient section where it actually gives us the regression equation, and we'll see the constant is 11.8. That means if I have no TV ads, I'll sell roughly 11.8 cars. And then as I increase, so then I go to my 3.5 is my beta coefficient on TV ads, and that says for each additional TV ad, car sales are predicted to increase by 3.5. and I look over here at that p-value, and that's the p-value for HO beta TV ads equals 0, and that's less than 0.05, so I would reject HO, and I find that TV ads does have a statistically significant impact on car sales. And again, notice that significance, that p-value is the same because in a simple regression, my f-test and t-test are running the same thing. I also can look at my confidence interval here. So this is my 95% confidence interval for my beta, my TV ads. So I'm 95% confident that for each additional TV ad, car sales will increase by 0.62, or by between 0.62 and 6.38 cars. I can also look on here to do a single-tailed hypothesis test. We'll discuss that like we saw in the Chapter 2 videos. Okay, now to do my predictive interval, what I'm going to do is actually click back from my data back from my output to my data itself. And what this is showing me here is my predictive interval and my confidence interval. So I have my predicted is going to be, so for if I have one TV ad, I predict sales of 15.3. If I have 3 TV ads, I predict sales of 22.3. And how is it doing that? It's literally just sticking it into the equation that we calculated. And if we look back, the equation we calculated, let's look back at our output, was car sales equals 11.8 plus 3.5 times the number of TV ads. So if I go back to my data editor here, I'm getting those predictions. So with X, TV ads being 1, my predicted car sales are 15.3. When X is 3, when TV ads are 3, my predicted car sales are 22.3. So those are my predicted Y's, my Y hats. And then the second two columns, first two new columns are my predictive interval. So I'm 95% confident that it's going to be within there. And then the second two columns are my confidence interval for that prediction. So the first two are my predictive interval, and then the second two are my confidence interval for that prediction.